Welcome to Silage Academy. In this video, we'll be learning how to use the laws of indices to solve some questions in index form. Alright, now before you go enter this video, please, if you have not seen my video on how we solve questions on using each of the laws of indices, I will advise you click on the card on the top right corner of your screen. Go and watch that video so you'll be able to learn and understand this one better. If not, you'll be lost in this video. All right, so let's go. We have 5 questions here, and I trust you this last one is mind-blowing, so I have to save the best for the last. Follow me through. For the first question, that's question number 1. It says we should solve for x. You have 4 raised to power x plus 1 is equal to 32. Remember, you can always pause this video and try some of these questions out yourself. Here, so the first thing we have to do here, we have to give both of them on both sides, the numbers on both sides, the same base. 4 is 2 raised to power 2, right? That's 2 times 2, that's 4. So we have this 2 raised to power 2, that's 4. Then remember, it has its own power here. So the power is x plus 1. Meanwhile, 32 is the same as 2 raised to power 5. So we have 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. So 32 is 6 raised to power 5. And next we are going to do here, we'll now apply the power law. This is the power law that says that when a number is raised to more than one power, the powers will multiply. So in this case, you have raised to power 2 and raised to power x plus 1. What it means is that the powers will multiply. So you have 2 raised to power 2 times x plus 1 is equal to 2 raised to power 5. It's very simple. What we are going to do here now is that the base will cancel. They both have the same base, that's 2. So their bases will cancel. When their bases cancel, you are left with the powers. That's 2 into x plus 1 is equal to just 5. Opening the brackets, you have 2 times x will give you 2x, 2 times 1 will give you plus 2. This is equal to 5. When you cross your 2 over to the other side, you have 2x is equal to 5 minus 2. Now, 2x is equal to 5 minus 2 will give you 3. That's 3. Now you have to divide both sides by the coefficient of x, which is 2. So that x will stand alone. So divided by 2, divided by 2. 2 will cancel 2. So your x is equal to 3 over 2. And this is your final answer. The number 2 question says 2 raised to power x plus 1 plus 2 raised to power x minus 1. What we are going to do here, we are going to apply the indices multiplication law. That's the first law here. In this case, we have x plus 1, m plus n. So we are going to split it in this form. That will give you 2 raised to power x times 2 raised to power 1 plus the same thing is applicable here. 2 raised to power x times 2 raised to power, you have minus 1 is equal to 20. Having that here, we are going to factorize the common term here. That's 2 raised to power x, 2 raised to power is common. So applying that, we are going to factorize this. So we have 2 raised to power x here. When you bring out 2 raised to power x, what's left here? Just 2. So you write it here, 2 plus. When you bring out 2 raised to power x here, what's left is 2 raised to power minus 1. And remember, 2 raised to power minus 1 is same as saying, as we are applying the negative power law here. It has a negative power law, a negative power. When it has a negative power, it is the same thing as saying 1 over that same number with a positive power. In this case, it has a negative power. It's going to be 1 over 2 raised to power 1, which is also 2. And this is equal to 20. Having this, we'll just go straight. 2 raised to power x, 2 plus 1 over 2. So you have 2 whole number 1 over 2. If we are to convert this to improper fraction, is equal to 20. If you are to convert this to improper fraction, 2 times 2 is 4, 4 plus 1 is 5. So you have 2x, opening the brackets now, you have times 5 over 2 is equal to 20. Now, how do we make x stand alone? We are going to divide both sides by this coefficient of x. Let's just assume that this is the coefficient of x here. So we are going to divide both sides by 5 over 2 so that our x stand alone. We have 5 over 2 divided by 5 over 2. So 5 over 2 we cancel out. We are left with 2 raised to power x is equal to, this is 20 divided by 5 over 2. This is 20 divided by 5 over 2. When you change this to multiplication sign, this division sign to multiplication sign, you have 2 raised to power x is equal to 20 times the numerator becomes denominator. Why the denominator becomes numerator? Divided by 2 over 5. 5 in 5, 1. 5 in 20 is 4. 4 times 2 will give you 8. So you have 2 raised to power x is equal to 8. Now, 2 raised to power x is equal to 8. I will continue it here. Here. 2 raised to power x is equal to 8. 8 is same as 2 raised to power 3. 2 raised to power x is equal to 8 to 2 raised to power 3. That's 2 times 2, 4. 4 times 2, 8. So 2 raised to power 3 will give you 8. Now that's 2 raised to power 3. The basis we cancel out. Then your x is equal to 3. So this is our final answer. Now for question number 3, we also simplify 2 raised to power n plus 4 minus 2 raised to power 1 or just 2 times 2 raised to power n, all divided by 2 times 2 raised to power n plus 3. So this is very simple. It's almost similar to what we did in question number 2. The first thing we have to do, we are going to apply indices multiplication law here. Okay, here where you split this 2m raised to power n plus n, 2 raised to power n plus 4, you are going to split it, and this will be equal to, you have 2 raised to power n times 2 raised to power 4 minus 2 times 2 raised to power n, all of them over 2 times, you also apply indices multiplication law here, which is times 2 raised to power n times 2 raised to power 3. You're applying this indices multiplication law. Now, the next thing we have to do, we are going to factorize the common factor here, which is 2n. You have 2n here, you have 2n here at the numerator. So this is going to be equal to, when you bring out 2n here, what's left? You are left with just 2 raised to power 4. So you have 2 raised to power 4. Then you bring out 2n here, you are left with just minus 2. So minus 2. Bracket close. All of them over 2 times 2 raised to power n times 2 raised to power 3. So this is very simple. What we are going to do, we are going to cancel out 2n, we cancel out 2n. You are left with 2 raised to power 4 minus 2 all over 2 times 2 raised to power 3. So 2 raised to power 4 is 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. So that's 16 minus 2 divided by 2 times 2 raised to power 3. So 2 times 2 raised to power 3 is 2 times 2, 4, 4 times 2, 8. So that's 8. Now this is going to be equal to, I'll continue it here. This is going to be equal to 16 minus 2 will give us 14. we have 14. This is equal to 14 over 2 times 8 will give us 16. So you have 16. Now we are going to break it down to its lowest term. 2 can go in 14. That will give you 7. And also 2 can go in 16. Will give you 8. So your final answer is 7 over 8. This is your final answer. This is a very light one. What we are going to do, we are going to apply this fractional index law. This unit fractional index law. Okay. This is the nth root of a. You convert it to a raised to power 1 over n. So this is the third root of this is 4r raised to power 6. We will convert it to this raised to power 1 over 3. So we are going to be having 64r raised to power minus 6, brackets close 1 over 2, then all of them in another brackets now, raised to power 1 over 3, according to this law here, the seventh law, the fractional index law. Okay, now when you have here, we'll not apply the power law that says that when a number is raised to more than 1 power, the powers will multiply. So these powers will multiply. You have 64 r raised by minus 6 raised to power 1 over 2 times this power now times 1 over 3, which is very simple. So you have 64 r raised by minus 6 all raised to power 1 times 1 is 1, 2 times 3 is 6, all raised to power 1 over 6. Now we'll be applying this last law here. Okay, we'll be applying this last law here. So what it means is that everything in this bracket is carrying this power. As you can see, everything in this bracket is carrying this power n. So that's what we are going to do here. So 64 will carry this power 1 over 6. R raised by minus 6 will also carry 1 over 6. So here we have, I'll give us 64 raised to power 1 over 6 times r raised by minus 6 times 1 over 6. Here the 6 we cancel out, then and this will not apply the fractional index law here. Okay, now when a number is raised to a fraction, the roots, the denominator will be the root of that number. So this is going to be the 6th root of 64. We have the 6th root of 64 times r raised by minus 1. The 6th root of 64 is 2. So we have 2 times r raised by minus 1. We are going to apply the negative power law here. That when a number is raised to a negative power, it is going to be equal to 1 over that number raised to a positive power. So it is going to be times 1 over r, and 2 times 1 over r will give you 2 over r. So this is our final answer.